Want to build a thermal mechanical model in OpenRadius? In this series, I will show you how using ls prepost in Python, starting with model setup and then converting it step by step. Let's start by creating a base plane for the workpiece. Go to Geometry, Plane, and define a rectangular plane. Use dimension like, for example, 50 by 10 millimeters to represent the workpiece surface. Click Apply and close the window. Create tool points. Now we define the tool shape using points. Navigate to Geometry Points. Click to place series of points that outline the forming tool. This will later define the profile of the tool. Create line from points. Next, link those points using lines. You can also create the lines without the points. Go to Geometry, Line, from points or via line icon at right. Click each point pair in sequence to form the tool outline. Once done, click Done and close the dialog. To generate the tool surface, go to Geometry, Fill Plane. Select the line you just created and click Apply. We will begin by extruding both the workpiece and the tool by 0.2 millimeters. We will use the extrusion icon located 6 from above. Both bodies are positioned simultaneously to maintain alignment and allow proper chip formation. Next, we move on to meshing. Go to the Mesh tab and select the third icon from the top, Solid Mesher. We start with the workpiece. First, we try an initial element size to get a rough mesh. Then we refine it slightly smaller than 1/10 of a millimeter, so we can accurately capture chip formation and stress location near the contact zone. We click on Hint to automatically set the target surface and then click on Mesh and Accept. Once satisfied, we move on to the tool. Using the same measure, we assign a coarser mesh since the tool remains elastic and doesn't require fine resolution. With both meshes complete, the model is now ready for boundary condition setup and simulation. First, we will go to the Entity Creation dialog box. This, along with the card editing windows, is one of the two most commonly used tools when setting up model parameters in ls prepost. You can access the Entity Creation tool through the third icon from the top in the Model section. Now let's create an SPC, which is a boundary condition. This condition can be defined either from a node set or directly from nodes. In this case, we will use a set. Click on Create, then choose Set, and now we will select the nodes using the Area Selection method. This allows you to quickly grab all the nodes in a specific region. Once selected, you can apply our SPC condition, for example, fixing displacement in one or more direction. In this case, we will fix all the nodes of the bottom. In this case, we will fix all the nodes at the bottom of the workpiece. Now we are going to create the contact segments. It's done through the same entity creation process, but this time we will head to the bottom part of the tree of the left side. Click on Set Data and then go to Set GM. Once you're there, hit Create to start the tool. We will begin by selecting all the zones of the workpiece that are going to come into contact with the tool. Make sure to rotate and zoom as needed so you can grab every relevant face. Don't leave anything out. This step is key because these segments will define the interaction between your workpiece and the forming tool during the simulation. Once selected, we will be ready to move on to defining the tool side of the contact. To generate a curve, we will use the Keyword Manager, located second from the top in the left panel. This will be one of the most frequently used dialogues in ls prepost. After opening it, we will create 3 points to define our curve, allowing for a smooth acceleration phase of the tool motion. To create a boundary prescribed motion or BPM, we will use a Create Entity dialog box. Like most things in LS Prepost, this will generate an LS-Dyna QR card behind the scenes. In the BPM setup, we will choose the degree of freedom we want to control, define the type of motion using 0 for displacement or 1 for velocity, and then assign it to a node set. This allows us to drive motion exactly how we need it for our simulation. We will fix the lateral boundaries on both tools and workpiece through the entity creation box and selecting both sets. In the case of tool, we also fix vertical direction since tool is moving only in X direction. To generate a Johnson Cook material in LS-Dyna, using Keyword Manager, go to Model, Materials, Add Material, and from the list, select Johnson Cook. Enter the material ID and name, then fill in the key parameters, density, ion modulus, and Poisson ratio. Next, input the Johnson Cook constants A, B, and C and M. Don't forget to set the reference strain rate and the melting temperature. Click Accept to save it, and your material is ready to assign. For a simple elastic material, choose Material Elastic. Just enter the density, ion modulus, and Poisson ratio. No other constant needed. Accept it and you're good to go. To create a solid section, go on to Keyword Manager and select Solid Section. Choose Solid, give it a section ID and name, then click OK. That's it. Now let's assign section and materials. In the left tree, check which part is the workpiece, usually the one with more elements, in this case part 1. Select that part on the Keyword Manager and assign the solid section and choose Johnson Cook material we created earlier. Next, select the second part, the tool. Assign the same solid section if the mesh is similar and set it to material to elastic 1. Accept and done. You have now defined both parts, reassigned sections, and linked the correct materials, ready to run your simulation. If you're into FEM, SPH, CFD, remeshing, or just enjoy watching solids get squished by clever math, you're in the right place. I dive into open source solvers, CPU acceleration, and how these methods actually work under the hood. So hit subscribe, or better, hop on the mailing list at opensourcemech.com. No spam, just good stuff. And if you want to support or ask deeper questions, there's always my Patreon. Thanks for watching and happy coding!